So in this video, we are going to learn how to find velocity vector and acceleration vector. Let's say we have an object at this point P here. And my question is, where exactly is this object? Or what is the location? What is the position of this object? To find that, we need a coordinate system. In kinematics, we use Cartesian coordinate system with x, y, and z axis. We're going to talk about a two-dimensional problem. So let's stick to x, y coordinate system. Right? X, y Cartesian coordinate system. A two-dimensional one. Okay, I'll draw that. So we have x-axis here, y-axis here. I'm going to mark some points. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Alright, so because we have a coordinate system, we can define the position as P is at 1 unit on x-axis and 6 units on y-axis. So we can write the coordinates of this point as 1, 6. Okay, so that's the position of this object, right? Yeah. So if you draw a vector connecting the origin and the position of the object, you call it a position vector. So this is position vector, let's call it position vector 1. R1, it's a vector. Position vectors are denoted using letters R, X, Y, or Z. Okay, now let's say this object starts moving from this point P to a different point Q. This is my point Q. So after a particular time t, delta t, object has reached Q. Right? So how do you draw the position vector of this object now? From the origin to point Q. That's position vector, let's call it position vector 2. Okay. So what's the new coordinate? 5 units on x-axis and 3 units on y-axis. So 5, 3. That's the coordinate of point Q. Now, if you draw a vector from point P to point Q, yes, okay, this is that vector, and we call this vector displacement vector, and it is represented using delta R. That's the displacement of the object. And how do you find the displacement? Delta R equals final position minus initial position, R2 minus R1. And this is called displacement vector. Our object has moved from point P to point Q. And that vector, we call it displacement vector, delta R, R2 minus R1. Now, if you divide displacement vector, okay, delta R by delta t, the time taken to reach point Q from point P, you'll get velocity vector V. It's average velocity, delta R by delta Q, average velocity. So average velocity is the total displacement over total time, or total time interval. So I can expand delta R. So V bar equals R2 minus R1 over delta t. And that is average velocity. For example, if Okay, I'll draw a picture. Okay, a car is moving from this point P to this point Q. Yeah, it's moving to the right. Let's say point P, position P is, I don't know, 5 meters, right? Yeah, and position Q, let's say 10 meters. To reach 10 meters from 5 meters, the car took 5 seconds, right? So this is my initial position, R1. This is my final position, R2. And this is my time interval, delta t. How do you find the average velocity? Average velocity, v bar equals final position minus initial position divided by the time interval, 5. So 5 by 5, 1 meter per second. Meter per second is a unit of velocity. Alright, so we got the velocity of the car as 1 meter per second. But that doesn't mean the car has always traveled with the same speed, right, or same velocity, 1 meter per second. This is just an average, the total displacement over total time interval, right? I don't know, maybe at this particular point, when the car has reached this particular point, the velocity, I don't know, has increased to 2 meters per second. At this particular point, velocity is 0.5 meter per second. We don't know. That the total distance or total displacement by total time, you'll get just average velocity, right? But from this value, we can't really say what exactly the velocity of the car at a particular time, right? It's just an average. The velocity at a particular instant, we can call it instantaneous velocity. Instantaneous velocity. Or if I ask, like, what is the velocity at time t equals 2.5 seconds, that's instantaneous velocity, right? The velocity at that second, 2.8 second. Or what's the velocity at 4 seconds? That's again instantaneous velocity. That's not average. Okay, so how do you find instantaneous velocity? You have an equation for that. Yeah, this is the equation. Velocity as a function of time is equal to d by dt of the position vector as a function of time. This d by dt is differential of position vector, d by dt of r of t.